Moving on with Unit 5, we are at the last part of learning Target 5B, and in this video we will learn about how to find the x and y intercepts of any line, then use those intercepts to draw our line, and lastly we will learn how to determine whether a line is vertical or horizontal. In addition, we are going to talk about the last type of line equation that we have. In our prior two videos we talked about what slope-intercept form is. That was in the first part of learning Target 5A, was what slope-intercept form was. Now as a review, why don't you guys pause the video and write down the equation for slope-intercept form. So slope-intercept form, remember, is that y equals mx plus b equation, where m is our slope and our y-intercept is 0, b. Remember, we always need to make sure that we're writing our y-intercept as a coordinate pair. So that was in the first part of learning Target 5B. Then in the second part of learning Target 5B, we learned about point slope form. Why don't you guys pause the video and write down what the general equation for point slope form is. Our general equation for point slope form is y minus y1 equals m times x minus x1, where again m is our slope and x1 comma y1 is that coordinate pair or that point that we are given. So that's the two things that we have talked about in learning Target 5B so far, slope-intercept form and point slope form. The last equation for a line is what we call standard form. So the standard form of a linear equation is of the form a times x plus b times y equals c, where a, b, and c are all real numbers, and then a and b both cannot be 0, otherwise we would just end up with 0. The reason we have standard form is if we were to write it as we solve for the constant. So both x and y are on the same side in standard form. Standard form doesn't give us information that is readily available, like slope-intercept and point slope form both had pieces of information that I could easily identify from the equation. So in slope-intercept form, we could easily identify the slope as our m value and use the b value to help us write our y-intercept. Likewise, in point slope form, I could readily identify our slope and then our coordinate pair being that x1 and the y1 value. Standard form unfortunately doesn't let us identify either the slope or any other information quickly, but it is our third equation of our line that we could write it in. The next definition that we need to talk about is what an x-intercept is. So an x-intercept of a graph is the coordinate pair where the graph crosses the x-axis. Way back at the beginning of learning Target 5B, we talked about what a y-intercept is. Remember, a y-intercept is where the graph crosses the y-axis. So for our lines, we could have both an x and a y-intercept, and we're going to start this video off by finding those. So to find a y-intercept, we would set x equal to 0 and we would solve for y. The reason we do that is a y-intercept is where we cross the y-axis. So if I draw a graph here, my y-intercept would be some point up here. The reason we set x to 0 is, although I'm not exactly sure what the y value is here, I know that I did not move left or right, which means my x value has to be equal to 0. And then from there, we could solve for y to get that y value of the coordinate pair. For an x-intercept, we're going to do the opposite. We're going to set y equal to 0 and solve for x. The reason being is on an x-intercept, I don't know how far I moved left or right, but I know for sure I did not move up or down, so the y-coordinate is always 0 in an x-intercept. So in this green point, that would represent our x-intercept, where our y-coordinate is always 0, which is why we set y equal to 0 to solve for x. And then on the flip side, we have a y-intercept with our blue point, and that always happens when x equals 0 and we solve for y. Let's try an example. So in examples 1 and 2, it says find the x and y intercepts for each of the following lines. In example 1, we're given 3x plus 4y equals 24. Let's start by finding our x-intercept. So in this problem, we are asked for two things, which means I will have to separately find my x-intercept, then get that answer, and then separately find my y-intercept and get that answer. So we are going to end up with two final answers, and they will both be written as coordinate pairs since x and y-intercepts are coordinate pairs. So we want to make sure we have our coordinate pairs as our final answer. So to find an x-intercept, we're going to set y to 0. So I'm going to substitute 0 in for y. I'll still have 3x, but now I'll get plus 4 times 0 equals 24 by substituting in y equals 0. From here, 4 times 0 is just going to be 0, so we end up with 3x equals 24. Our last step then is to divide by 3, and we get x equals 8. What that tells me then is that my x-intercept is going to be 8, 0. Since y was equal to 0, I have a 0 in the y spot, and that gave me a value of 8 to go in our x spot. That's half of the problem for example 1. The next half is I need to also find my y-intercept. So we're going to do the opposite here. To find our y-intercept, we're going to set x equal to 0. So we get 3 times 0 plus 4 times y equals 24. Simplifying this down, 3 times 0 is just 0, so we end up with 4y equals 24. Dividing through by 4, we end up with y equals 6. That tells us that our y-intercept then is going to be 0, positive 6. Remember, the 0 is coming because we set x equal to 0, and that will always happen with any y-intercept. So in example 1, we have two separate answers here, an x-intercept at 0, 8, and a y-intercept at 0, 6. Let's look at example 2. It says 5x minus 6y equals 60. We need to find both the x and the y-intercept. Why don't you guys pause the video right now and find the x-intercept for example 2. Let's check our x-intercept. Remember, to find our x-intercept, I'm going to set y equal to 0. So we get 5x minus 6 times 0 equals 60. Well, negative 6 times 0 is just going to be 0. We end up with 5x equals 60. Dividing through by 5, we get x is equal to 12. That tells us then that our x-intercept is going to be 12, 0. And that will be our answer for our x-intercept. Why don't you guys pause the video and find the y-intercept in example 2. For our y-intercept, we're going to set x equal to 0 now. So we get 5 times 0 minus 6y equals 60. So 5 times 0 is going to give us 0, but I still have that negative sign that's attached to the 6y. So I get negative 6y equals 60. Dividing through by negative 6 gives me a negative 10 for y, which tells me that my y-intercept is going to be 0, negative 10 then. And that will be our answer for our y-intercept. So again, in example 2, since we're finding both the x and the y-intercept, I'm going to get two separate answers, since each one of those is their own coordinate pair. Okay, let's look at what happens if we extend this concept to graphing. Whoops. Sorry, you guys. Let's scroll back to, that was where our past 3 videos already. There we go. So let's look at example 3. It says find the x and y intercepts for each of the following lines, then we need to graph it. So we're going to do the same thing we did in examples 1 and 2, and then use that information to help us graph. So right now, why don't you guys pause the video and find your x-intercept for example 3. Remember, for our x-intercepts, we're going to set y equal to 0. So we get x minus 2 times 0 equals negative 2. So 2 times 0 will give us 0, and we end up with x equals negative 2. That tells us that our x-intercept is going to be the coordinate pair negative 2, 0. So we've done part of this problem. The next step in this problem is to find the y-intercept. Why don't you guys pause the video and find your y-intercept? Remember, for y-intercepts, we're going to set x equal to 0 now. So I get 0 minus 2 times y equals negative 2. Well, that's the same as just negative 2y equals negative 2. Dividing through by -2, we end up with y equals +1. That then tells us that our y-intercept is going to be at 0, +1. Don't forget about this negative sign here that's attached to the 2y. Although 0 and the x term is going to go away, that negative sign is still there. Now that we have our x and our y-intercept, we can go ahead and graph this. We know that this is going to be a straight line, and in fact, I forgot to mention it, but in examples 1, 2, and 3 here, all of these equations were in what we call standard form. So see how we have a number times x plus a number times y equals a number? That is our standard form, even if some of the numbers are negative. So in examples 1, 2, and 3, all of those equations of our lines were in standard form. That's actually a really nice form to find our x and our y-intercepts in, which is why we started with it. Now that I've found both of them, I have 2 points. So if I go to plot these, I'm at -2, 0. So I go to the left 2, and then I don't go up or down. For our y-intercept at 0, 1, I don't go right or left, I just go up 1. I am going to go ahead and label these points just to make sure we know which one's which. So our x-intercept here is at -2, 0, and our y-intercept over here is at 0, +1. Now that I have 2 points graphed, that's all I need to get the graph of a line. So using my straight edge, I can draw, or my ruler, I can draw the graph of my line here, and I just want to make sure I extend it across the entire coordinate plane. So in example 3, we had to do 3 things. Find the x-intercept, find the y-intercept, then we can plot both of those points and use them to connect and get our straight line, which also gave us the graph. So here's a third way that we can actually graph. We've seen graphing in both of the prior 2 videos, and this is one other way that we can get a graph of a straight line. Let's look at example 4. Why don't you guys pause the video and find your x and your y-intercept in example 4 first, and then we'll check those together. Okay, let's check our x-intercept. So to find your x-intercept, remember we set y equal to 0. So I'll get 2x plus 5 times 0 equals +10. 5 times 0 is just going to give me 0. I end up with 2x equals 10. Dividing through by 2, we get x to equal 5. That then tells me that my final answer for my x-intercept will be 5, 0. Remember, we always want to make sure we write those intercepts as coordinate pairs. And since x is 5, the 5 goes in the x spot, and since we set y equal to 0, that's why we have a 0 in the y spot. Okay, let's check our y-intercept. So this time we're going to do the opposite, and we're going to set x equal to 0. Equal to 0. So we get 2 times 0 plus 5y equals +10. 2 times 0 is just going to be 0. We end up with 5y equals 10. Dividing through by 5 will give us y is equal to 2. That can then tell me what my y-intercept is. So since I set x to 0, I get 0, I got 2 for y. So my y-intercept will then be 0, 2. Now that we have our 2 intercepts, why don't you guys go ahead and plot both of those points and then graph your straight line? Okay, let's check this. So I'm going to graph my x-intercept first. So at 5, 0 means I go to the right 5. 1, 2, 3, 4, 5. And then I don't move up or down at all since 0 is in the y spot. I'm going to go ahead and label that. So that will be 5, 0. Our y-intercept is at 0, 2, which means I don't go right or left. I just go up 2. And I plot that point. I'm going to go ahead and label it. So we're at 0, 2. Now that I have 2 points, I can connect them together to form my straight line, and I'm going to just make sure that this graph continues out all the way. So using either a ruler or some type of straight edge that you might have, maybe the side of your notebook, you want to go ahead and connect those dots and draw your straight line. So in both of these examples, we practice starting with an equation in standard form. So our standard form is where x and y are on the same side of the equation and they equal a number. So starting in standard form, I can find the x and the y-intercept individually on their own by setting the opposite variable equal to 0. So to find the x-intercept, remember we set y to 0 and solve. Then to find the y-intercept, we set x to 0 and then solve. That then gives me two separate answers, one for the x-intercept, one for the y-intercept. I can plot both of those points and then graph my straight line from there. Hey, the last part in this section has to do with the difference between horizontal and vertical lines. So in these examples, it says determine if the line is horizontal or vertical, then graph. So example 5 says x equals +3. Well, I need some points. We know that to graph a line, I need 2 points. So I'm going to find some points, and let's think about how we can do that. So to find some points, all I know is that x equals 3. So that tells me that in any coordinate pair I have to have 3 comma something. It doesn't actually matter what the y value is as long as the x value equals 3. So in this line, although we're not sure yet if it's horizontal or vertical, I only have information about x, which tells me that the x coordinate has to be equal to 3 and the y coordinate can be whatever 2 numbers I want to pick. So for the sake of this, I'll do 0 and then I'll do -4. Let's do those two as our coordinate pairs. We could also do 3, 1. We could do 3, -2. I could even do 3, 100 would give me something on x equals 3. All that I need to be true is that x has to be equal to 3 in my coordinate pair. I'm going to go ahead and plot 2 of these. So 3, 0 would be to the right 3, 1, 2, 3, and then I didn't move up or down, so that will be 3, 0. Then 3, -4 means I go to the right 3 and then I go down 4. Since I have 2 points, this is enough to graph a line. And as I go to connect these together, I notice that I am going to get a vertical line. Whoops. Here we go. I'm going to get a vertical line going through these two. Let's just make that a little bit thicker so we can see it. Ooh, there we go. So I'm getting this vertical line that is going straight through them. So when I have x equals a number, that produces a vertical line that I end up with. I could plot more points on there, even if I plot 3, 1 or 3, -2 or even 3, 100 way up here, I would still be getting this vertical line shape. Let's look at example 6. So example 6 says, determine if the line is horizontal or vertical, then graph. This time we have y equals -1. So I'm going to go ahead and find some points. So in this case, all I have is information about what y is equal to, which means that in any of these coordinate pairs, the y spot has to be equal to -1. It does not matter what the x coordinate is, as long as the y coordinate is equal to -1. So I'm going to pick one of the nicest numbers. I'm going to use 0, -1, and then how about I also use 3, -1. Let's go ahead and plot these. So 0, -1 would mean I don't go left or right, I just go down 1. So that is at 0, -1. Then 3, -1 means I go to the right 3 and down 1, and that will give me 3, -1. I can go ahead, now that I have 2 points plotted, I can go ahead and connect them, and we're going to see that we get a horizontal line that's going through this, and I'm going to just make it a little bit thicker so we can see that. So in this case, when we have y equals, this is where we end up with our horizontal lines. So we saw in example 5 that when we had x equals, that gave us a vertical line, and when we have y equals, that gives us a horizontal line. The way we went about thinking about it was, well, I need 2 points to graph, so if y equals -1, then both y coordinates have to be equal to -1, and the x coordinates can be any number we choose. Another way to think about these is the fact that I have y equals, it should be intersecting the y-axis, and that's why I'm also producing a horizontal line. Likewise, in example 5, when we had x equals, I needed to intersect the x-axis at x equals 3, and that is producing a vertical line. Let's look at two more examples. Why don't you guys pause the video and determine if the line in example 7, x equals -4, is horizontal or vertical. So in example 7, I'm going to go ahead and find our points. All we know is that x equals -4, which means that my x coordinate has to be -4 in all the points that I would have. And then I can pick my two favorite values for the y. So why don't I do 0 and 3? When I go to plot these, I go to the left 4, and then I don't go up or down since I'm on a x-intercept. Then -4, so let me write that. That would be -4, 0. And then -4, 3. It's going to be to the left 4 and then up 3. And I'm at -4, 3 there. Now that I have 2 points plotted, I can go ahead and connect those together and get our straight line coming down. Let me just make it a little bit thicker so that we can see it. So in this case, again, since we have an x equals, we're getting a vertical line. And in our last example here, you guys have y equals 2. Why don't you pause the video and graph that line? So for y equals 2, I don't know what the x coordinate can be. The x coordinate can actually be any number, just the y coordinate is being forced to be 2. So I'm going to pick two values for x. Let's do 0 and let's do -4 this time. When I go to graph those, 0, 2 is a y-intercept, and then -4, 2 would be right there. So I have 0, 2, and then -4, 2. If I connect these together using my straight edge or my ruler, I'm going to end up with a horizontal line, and let's just make it a little bit thicker so that we can see it. So in this case, we're back to having a horizontal line because we have y equals a number. So if we summarize this down here, vertical lines are always of the form x equals a number, because we're intersecting the x-axis then, which is producing the vertical line, and a horizontal line are always of the form y equals a number. So vertical and horizontal lines happen when we only have one of our two variables. So if I only have x equals a number, I'll get a vertical line. Remember, our vertical lines are the lines that are going up and down. So in this case, this would be a vertical line, my x and my y axes, and then a horizontal line happens when I just have y equals a number, and remember, a horizontal line goes side to side. So there's two graphs to go with those. And that is the end of learning target.